So I have the first one up, rigid transformations. The word rigid just means that we're not changing anything about the angles or the lengths of the sides. So we're going to move this shape. We're going to translate. Back in elementary school, they learned it as a slide. And we're not going to change anything about it. We're going to keep everything the same, lengths of sides, angles. One strategy that we show them in class is to use tracing paper. We can show the students that they can trace this. So we'll have them take a pencil and just do a little rough trace of the shape, trying their best to keep it as close as possible to the original. This is nice because they keep the original on their paper. Then with their tracing paper, they can slide this and get it into location. Okay, so if I know I want to take this triangle and I want to translate this triangle so that point A is 10 units to the right, I'm going to take my pencil and I'm going to mark those locations. So I have to go 10 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put like a little marker there. So that's my 10 units to the right. And then I'm going to move 3 down. 1, 2, 3. This is where A is going to be translated. Okay, that is the location. So I can take my tracer and I can see that this is where it will go. If I want to replicate this on my paper, well, I know this is 5 centimeters, so if I have a ruler handy, I could come over here and do 5 centimeters. That would take me to here. Okay, so remember, nothing is changing about my triangle. So if this is A, this is going to be B. And I can see that this is 3.5 centimeters, so I'm going to come over here and do 3.5. Okay. Now, all I have to do is connect my A and my C, my hypotenuse, and I've just translated. Now, how do we code that this is a copy? We use these little dashes, these little apostrophes, and this lets us know that this is the copy of the original shape. So when we're translating, all we're doing is moving, and we use the term move along a vector. So what that means, the vector is just that arrow, that location, we're taking from A to this point and then from this point down. So when we are doing translations, we do want to be careful. We're not doing diagonal moves, we're following a grid. So it's going to be either to the right or to the left, up or down. That is translations. So I'm going to show you 2 different types of reflections that we can do. So my first one, I'm going to say we're going to do a vertical reflection. And we're going to use point C as our vertical line. So I am going to make a vertical reflection over this line. And I'm using point C as my point where I'm going to reflect it over. Okay, so I'm going to grab that tracing paper. Now for this one, if I reflect it over this line, I'm literally just going to flip the paper and see that everything is just going to be reflected backwards. See that? This is why the tracing paper is really good to use. It's a good visual, especially for students who just need to see it and move it with their hands. So now I see, okay, this is what the reflection is going to look like. So let's see if we can draw it. Now that we have that visual, we can see it. Just like we did with the translations, I can see that this line segment is 3.5 centimeters. So I'm going to reflect it 3.5 centimeters in the opposite direction. Okay, so this line is now reflected. Let's get that parchment paper back up here. And you can see that B is now over here, right? C is not really moving. It's staying in the same spot. It's backwards on my parchment paper. My C copy is going to be in the same location as my original C, and my B is here. Okay, and this line segment matches this line segment, 3.5 centimeters. Okay, now I'm going to replicate my AB again using the parchment paper. I can see, so this is 5 centimeters, so I can use my ruler and I can make a 5 centimeter line, mark my dot, connect. Okay, so now I have my A copy This is the easy part. Make the hypotenuse. This would be a vertical reflection. Copy A, B, and C. Now I'm going to do a horizontal reflection. And for my horizontal reflection, I'm going to use line segment BC. So I did my vertical reflection over point C, my horizontal reflection. I'm going to do that. I'm going to use BC as my reflection line. So again, pulling up my tracing paper, I can see that if I take this triangle and I want to reflect it down, I'm flipping it, and BC is going to line right up with BC. And my A is on the total opposite side there. Okay? So again, now that I can see it with my tracing paper, the only thing I really need to draw is the line segment AB. Okay, so we know that this is 5 centimeters. I can line it up and draw a 5 centimeter line. Okay, so there's B, and this is also a copy of B. This is a copy of A, and I'm going to draw the line. And then I can just connect here. Notice C is also not changing. C copy. This is my reflection horizontally. I'm flipping it down. Okay, and this 5 centimeter line is my 5 centimeter line here, and my hypotenuse is now here. These are reflections. So I find the tracing paper exceptionally useful for rotations. Students can sometimes struggle with seeing a rotation. So if I want to rotate my triangle ABC, so the directions may say rotate 90 degrees triangle ABC 90 degrees. And I'm going to stick with clockwise for this example. There's always a center of rotation. So we're going to say we're going to rotate 90 degrees around point C. Think of it as like the anchor, or if you have like a wheel, a tire, this is the center. And I'm going to rotate this around, and I'm going to use that. I might even use a pencil kind of to hold it into place. And I'm going to rotate it 90 degrees, which is just going to be one paper turn. So if I have my tracing paper, I'm just turning it one spin, going from horizontal to vertical. Okay. So this is what a 90-degree turn would look like. And this one is really hard for students to visualize without the paper. Okay, so I can see that my C is not moving and my B is right here. So I'm going to remove my tracing paper, and I know now that my B is going to go 3.5 centimeters up from C. So I'm just going to find that 3.5 and I'm going to mark my point. Okay, right there. So now this is my B copy. And I'm just going to draw the line. And I can see that now this B has rotated 90 degrees around point C. And then I can even show students, you can even show students like when they have a protractor, that this B to the new B is a 90-degree angle. See that? So we've just turned our shape 90 degrees. Now, I have to replicate my line segment AB. Now, where is that going to go? Is that going to go up top, or is it going to go at the bottom? And again, the tracing paper comes in handy because now I can go back and rotate it again one more time. All right, so I have my, oh look, see my B and my AB is at the top, not at the bottom. My hypotenuse is going to be here at the bottom. Now replicate their copy of line AB. And then the hypotenuse is done here. Okay? So my C copy. And I can label my sides. I can label my lengths because nothing is changing. Remember, it's rigid, so they can come over here and just relabel their copies.